welcome to our tutorial on understanding analysis of variance in R. Today, we will walk you through the process of conducting ANOVA in R, a statistical technique used to analyze the difference between the group means we have. Here, we have null hypothesis, no significant difference in the mean of population or a group. Alternative hypothesis is the difference in the mean of population, and we are using here alpha value 0.05. First, we need to load libraries like tidyverse and deuterium, and from deuterium package we load our anxiety data into R and make sure. So here we have a code. We run our libraries like a tidyverse and deuterium. It takes a few seconds to run both the packages, and we can see our packages are ready. And from the deuterium library, we use a data called anxiety. You can find this deuterium package on the CRAN, and it's a really nice package. It has some nice data set that we can use to do a statistical analysis. So here we use anxiety data, and I'm making a data vector called data n. N is stand for anxiety, and we run here this, and we can see from this package we get this data in a wide format. And here we have a group 1, 2 and 3, and the T1, T2, T3 are different time points in which the measurements was recorded, or we can see the read. So now at this point we need to make sure our data is properly formatted and structured before we proceed. Here, as you can see, our data is in a wide data format. Convert our data in a longer format, we use a tidyverse library and the function called pivot longer. You will find a video on how to use pivot longer in the I button of this video. So here we have a code how to convert the data in the longer format using the function called pivot longer. So here I choose pivot longer, and we have a function called column, and we choose the column, as you can see, 3, 4 and 5 to convert these reads into a longer format. So we have a column 3, 5, and we gives names to into observation and values to the read, and we have close here the bracket, and we save this all conversion into a data underscore longer vec, and we run this code of chunk, and we can see we got a table of 135 observations with the 4 variables, and all the T1, T2 time points are standing in a column called observation, and all the numerical values in the column read. So now we have a very nice longer format for our data. After conversion the data in the longer format, we will check the normality of the data using the Shapiro test, and here we come in the end of our data and we write Shapiro.test, and we give here our data vector in which we store our data $read, and we run this code here. The output of Shapiro-Wills normality test is showing us the W value, the statistics value, and the P value. And the P value here we can clearly see is greater than our alpha value of 0.05, which indicates that our data is normally distributed. Next, we check homogeneity of variance using the Bartlett test, and for the Bartlett test we write the function Bartlett test. Reads are our numerical vector and observation our categorical, and here we gives the data equals to data underscore longer, which is our data set. We make it to read our data in a longer format, and we simply run the Bartlett test here. The output of the Bartlett test shows a higher p-value 0.1871, and the k-squared value is 3.3, and degree of freedom is 2. So here higher p-value indicate that data has an equal variance. So we have enough evidence, or I will say that both the test of Shapiro and the Bartlett test provide enough evidence to use the ANOVA model on this data. So we comes next here, and we just write a VAC function called AOV. AOV fit our ANOVA model by calling a linear model for each data point in the data set. This function takes the form of a response variable and a factor variable. So here in our function we have a function called AOV, and we gives our response variable a read and the categorical vec observation, and our data is the same, data underscore longer, and we save this function in the model we assign as a AOV model, and then we want an output of this model as a summary. So we put a summary here of this model, AOV model, in the bracket, and we just run the code of chunk here, and we get output in the form of a table. Here we have a degree of freedom, sum is square, mean is square, F value, and P value. Here is important that P value, which is significant. As we can see here, our P value is 4.380 into 10 to the power minus 5, which is highly significant and lower than our alpha value of 0.05. To further analyze the result, we can use Taki HSV function to perform perform post hoc tests and determine which group mean are significantly different from each other, because at this point we don't know which of our observation group is highly significant. So we come further and write here Tucky HSD. We write here Tucky HSD, and in the bracket we give AOV underscore model, because this was our linear model, and we simply run this function here, and this function give us an output in the Tucky multiple comparison of means 95% family wise confidence level. And here we have observation or comparison between the different reads, like a T2 versus T1, T3 versus T1, and T3 versus T2. And we can clearly see that the p-adjust or p-value in which group is higher or which group have a significant. So our comparison between the T3 versus T1 is highly significant. As we see here, the p-value is 0.000236, and comparison between the group or read T3 versus T2 is also significant. So like this, performing a Tucky HSD test, we knows which group are rejecting the null hypothesis and have a significantly or accepting an alternative hypothesis. So that's for our tutorial on analysis of variance in R, and I hope you found this video helpful in understanding how to conduct and interpret ANOVA in R. Stay tuned for more insightful tutorials on statistical analysis and data visualization. Don't forget to like, share and subscribe for more content on data analysis and programming tutorials in R. Thank you for your attention.